You ever hear the word Linux and just, picture a black screen with glowing green text, something for super geniuses and hackers? Yeah, you're not alone. But the truth is, Linux is, well, it's everywhere. So, in the next 5 minutes, we're going to lay out a roadmap to help you finally get what it is and why it's so incredibly important. So, why should you even care? Well, let's start with this number 96.3%. That is how many of the world's top 1 million web servers are running on Linux. Just think about that. Almost every single time you visit a website, read an article, or stream a video, you're talking to a Linux machine. It's the invisible backbone of the internet. And it's not just websites. When you look at the absolute beasts of the computing world, the top 500 supercomputers doing crazy scientific research, 100% of them run on Linux. It is the undisputed king of high-performance computing. No contest. Okay, so if it's that powerful and that dominant, why does learning it feel like trying to climb a vertical wall? For a lot of us, the command line, those weird file structures, a whole new vocabulary, it can feel really overwhelming. And look, if you felt that, you're not wrong. It can be a steep curve. But we're going to cut right through that complexity. Let's build a simple roadmap together, right now. Over the next few minutes, we're just going to walk through the big ideas that make Linux tick, so you can walk away from this with a really solid foundation. All right, first stop, every great system has a core, a central piece that makes everything else work. For Linux, that's called the kernel. We're going to start right there, at the very heart of the machine. This right here, this is the Linux kernel. And honestly, when people say Linux, this is the piece of genius they're really talking about. It's the master translator, the bridge between the software you want to run and the actual physical hardware of your computer, your CPU, your memory, all of it. And that brings us to a huge point of confusion for beginners, the difference between the kernel and a distribution. The best way to think about it is like a car. The kernel is the engine. It's powerful, it's essential. But you can't just drive an engine down the road, right? A Linux distribution, or distro, like Ubuntu or Red Hat, that's the whole car. It takes the kernel engine and bundles it with the body, the wheels, the dashboard, everything you need to actually go somewhere. So, we've got our car. Now, how does it organize all its stuff? That brings us to the Linux file system. The easiest way to picture it is like a giant, super organized digital filing cabinet. And how do we look inside this cabinet? We use a command called ls-l. Now, this does more than just list your files. It shows you who has the keys to each one. You see that kind of strange-looking string of letters and dashes at the very beginning of the line? That little thing is the absolute core of Linux security. It tells us exactly who can read, who can change, and who can run that file. At first glance, it looks like nonsense, but it's actually super elegant. That string is just 3 sets of permissions for 3 groups. The first part is for the file's owner, that's you. The second is for the group, like a team you're on, and the third is for other, literally everyone else. So RWX means the owner can read, write, and execute it. But RR for everyone else means they can only read it. It's simple, but it gives you incredibly fine-grained control. And of course, you can change these permissions. The command for that is called chmod. Now, there are 2 main ways to do it. The symbolic method is pretty intuitive. It almost looks like English. But here's a little pro tip. You'll often see system admins use the octal method, where numbers stand for permissions. You don't have to memorize it, but if you see someone type chmod 754, you know you're watching a pro at work. It's just a really fast, efficient way to set those permissions. Okay, so we've got these permissions, and they act like locks on all our files. But who holds the keys? Well, that brings us to our next core concept, users and groups. See, on a Linux system, not all users are created equal. Way at the top, you have the root user. This is the super user, the god of the machine who can do absolutely anything. Then, for day-to-day stuff, you have regular users. Now, a special kind of regular user is a pseudo user who can temporarily borrow root's power for specific commands. And finally, there are service accounts, which aren't even for people. They're special accounts just for software to run securely. So what does it look like to actually manage one of these users? On the command line, it's a really simple 2-step dance. You use user add to create the account, then password to give it a password. And here's the cool part, what's happening under the hood. The system just adds one single new line to a file called atc password. That file is the master list of every single user on the machine. All right,
we've talked about the static parts of the system, the files, the permissions, the users. Now let's head into the engine room and look at the dynamic running parts of the system, the services.
Ever wonder what actually happens when you turn on a Linux computer? It's a really precise chain of events. First, the BIOS wakes up the hardware. Then, the bootloader finds our kernel and shoves it into memory. As soon as the kernel takes over, it hands off a super important job to a manager called systemd. And systemd's whole mission is to start up and manage all the background services that make the computer actually do useful things.
Now, this whole process used to be different. The old way, called sysv, was kind of slow, like a single file line where services started one by one. The modern way, systemd, is way smarter. It's like opening up all the checkout lanes at the grocery store at once. It starts things in parallel so the whole system boots up much, much faster. And for you, the command to remember today is systemctl. That's your control panel for the whole engine room. So what's a real-world example of one of these services that systemd is managing? A perfect one is file sharing. How do you get different Linux machines to talk to each other and share files over a network? A classic service for this is called NFS, or the Network File System, and the process is just beautiful. One computer, the server, basically just exports a directory saying, hey, this is available. Then another computer, the client, mounts that directory. And here's the magic. That folder from across the network now shows up on the client machine as if it were a local folder on its own hard drive. It's an amazing service that makes remote collaboration feel totally seamless. Okay, so we've got all these building blocks, right? The kernel, secure files, users, services. So why is understanding all this so critical right now? Let's zoom out and look at the modern tech landscape. A massive piece of this puzzle is virtualization. This is the wild technology that lets one single physical server pretend to be dozens of separate virtual servers. And Linux is the undisputed champion of virtualization. That capability is exactly why it became the foundation for the entire modern cloud. And this is why this stuff matters. Understanding these fundamentals isn't some niche skill anymore. It's the bedrock of modern technology. The entire cloud as we know it, AWS, Azure, Google Cloud, it's all built on Linux. That whole container revolution with Docker, powered by core Linux features. Put simply, if you want a career in tech, getting a handle on these building blocks isn't just helpful, it's absolutely essential. So in just a few minutes, we've gone all the way from the kernel at the heart of the system to its role powering the entire global cloud. You've got the map now. The only question left is, where's your Linux journey going to take you?